So now we're going to look at how we measure the energy content in fuels using the calorimetric method. This is when we measure the energy content in fuel by heating water. So here I've got two fuels I want to test, fuel A and fuel B. The first thing I do is weigh one of the fuels. For that I will need a top pan balance, what you might call weighing scales. So I'm going to take my fuel, I'm going to place it on top pan balance, I'm going to record down the mass. So I've weighed it and the mass is 34 grams. Notice how to draw a table properly. The independent variable always goes in the left-hand column. In other words, what you change in the experiment. So I'm changing the type of fuel. And the dependent variable, in other words, what I measure, which is mass, go in the next few columns. Also notice how I've put the units here, and by doing that with this little line here called the solidus line, that means I don't have to keep on putting units when I write numbers, because that says that all these are measured in grams. Next, I have to get a fixed volume of water in a beaker, so I'd use a measuring cylinder to measure water in a beaker, so it's a fixed volume that has to be controlled in this experiment to keep it a fair test. You then set up a draft shield. This can be anything, some sort of structure which prevents any draft from blowing the flame away from the beaker, as this could stop the amount of energy being transferred directly to the beaker of water, and that will make it an inaccurate test as well. So now I put the thermometer in the water and allow it to reach the correct temperature, give it a few minutes to acclimatize so I actually get an accurate reading of the water temperature. Once that's happened, I put the fuel underneath my beaker and I light it. Now what I'm hoping to observe is a temperature rise by 10 degrees Celsius. That's when I stop the fuel from burning or heating the water and I quickly blow out the flame. So light the fuel and heat the water by 10 degrees Celsius. When that's happened, I take the fuel and I re-weigh it. And let's say this time it's 25 grams. So I've burnt, in other words, the difference of 9 grams of fuel. So in other words, it's taken 9 grams of fuel A to heat the water by 10 degrees Celsius. So now we do exactly the same with fuel B. Remember to replace the water here and then take the temperature again so you reset the experiment. And also make sure that you have a fixed volume of water, the same amount as last time, because if you put more water in there, it would take longer to heat up and that would be an unfair test. So let's take fuel B and weigh it, and let's say that it comes to a mass of 42 grams. Then I take fuel B, I place it under the beaker and I light it. And once again I wait and observe for a 10-degree rise in temperature. When this happens, I blow out the flame and I re-weigh the fuel. And this time the fuel has 37 grams of mass left. So in other words, the difference is 5 grams. So which fuel contains more energy per gram? Don't misread the figures here, it's not the higher number. Remember what we're saying here is it only took 5 grams of fuel B to bring about a 10-degree rise in the water temperature, whereas it took 9 grams of fuel A to bring about the same rise. So you needed less of fuel B to bring about the same temperature rise. So obviously fuel B has more energy in it per gram. Just remember the basic controls here. Fixed volume of water, make sure you're observing for a fixed temperature rise, and make sure you have a draft shield in place so the flame doesn't blow away from the beaker.